Let's take a look at number 17 on the Unit 3 review. We need to find all these different angles. I'm going to start out here, noting this is 90 degrees. And from there, I'm going to say, well, angle E must be part of this 180 degree angle. So 64 plus 90 is 154, so angle E must be the supplement to that, which would be 26. So E is equal to 26 degrees. And then, would like to say this is a 90 degree angle, but we don't know that this line is parallel to this line. So I cannot say that. I'll start working here. This is 78 degrees since it's vertical of this angle. And so this is a straight line, so we get 180. So 44 and 78 will give us 122. The supplement of 122 is 58. So F is 58 degrees. Okay, make sure I did that right. And then looking down here at these guys, I know that since these lines are parallel, this one single transversal here will form corresponding angles between the 78 degree angle and angle B. So angle B is 78 degrees. And then we know angle A must be supplementary to angle B. Here. Boom, boom. So supplementary to 78 degrees is 102. And then let's see. We can see that this line here is a transversal of our two parallel lines. So angle C and this angle here are congruent by alternate exterior angles. So angle C should be the same as angle F. You can see vertical angles there. We could have done the math here saying, oh, well, this is 180 degrees, so that small little angle here should be the supplement. Okay, and then angle D must be supplementary to that. So, supplementary to 58 degrees is, where are we at? D. Supplementary to 58 degrees is 122. And it looks like we have all the angles. Let's look at some of these real quick. Write an equation of the line passing through point 8, 2 that is parallel to the line 6x minus 9y equals -7. So what we can do is, first we really want this in slope-intercept form. Let me take that off. So y equals mx plus b. The way we're going to do that is I'm going to add 9y to both sides and then add 7 to both sides. So I get y is equal to 6x plus 7, 9y, and then divide both sides by 9. 6 divided by 9, that will reduce to 2/3. And then 7 divided by 9 is 7/9. This is actually really negligible here because we're really looking at the slope of the original line. 2/3. So if the slope of this line is positive 2/3, we need the slope of our line that is parallel to be opposite sign, so it's negative, and then the reciprocal. Now I don't know what the y-intercept is, so I'm just going to write b right here. You can use point slope form if you want to do that, in which case this would be x1, y1, and you would just use point slope form. I prefer to do it this way. It allows me to plug in my y, which is 2, and then my x, which is 8. Now if I evaluate this, I get 2 is equal to negative, no, that's actually 24. 24 halves, which reduces to negative 12. Oh, the x is gone. Why do I have that x there still? I got distracted. So if we add 12 to both sides, we'll find that b is equal to 14. So I'm going to rewrite this but instead of writing b, I'm going to write what we found b is equal to. Okay, so if we plot these out, just want to show you. And the original was y equals 2/3 x. And I'll just put the original y-intercept. Okay, this isn't working. Either way, if I plot these out, positive 14, down 3 over 2, get something like this. And then for this line, I'd have 7/9, which is less than 1, and we go up 2 over 3. And it should be perpendicular to it, whilst the line, this line here passes through 2, 8. Is that right? No, 8, 2. That point there. Okay. Let's do this problem here. What is an equation of a line perpendicular to? Oh, cool, it's already in slope-intercept form. So we have the slope of 2, or 2 over 1. So my new equation, which is perpendicular to this, should have a slope of negative 1 over 2, because it's the opposite sign, and it's the reciprocal. And then we need to figure out what the y-intercept is going to be. So we're going to plug in this point. Our point is 8, negative 4. So I'm going to plug in negative 4 for my y, and 8 for my x. And then I find out when I evaluate negative 1/2 times 8 that our b value must be 0. So since b equals 0, I do not have to write it here. My answer will end up just being y equals negative 1/2 x. So I'm going to erase this and put this here. Write an equation of the line passing through the point 3, 8 that is perpendicular to the line. Y plus 8 equals. So this actually, the important part of this is it shows your slope right away. This is in point slope form. Even if we distributed this, we would find out after distributing it and getting y equals mx plus b, our m will be the same. So what's important here? The slope. And we need a line that's perpendicular to a slope of negative 2 over 13. So our slope on our new line will be change the sign, so it's positive, and then flip the fraction. This is called the reciprocal. So I plug in this point. Let's see, 3 times 13 should be 39. And then I need to subtract 39 halves from both sides. And 8, if I were to cut it into halves, we would have 16 halves. So doing this allows me to actually combine these terms, since they're both in halves. The difference there is, let's see, 23. So our b value is negative 23 halves. So we'll come back here, rewrite this, but instead of writing b, we're going to write what we found b is equal to, negative 23 halves.